Now the third, well not the third actually, I said that wrong, but this type of triangle we're talking about is an isosceles triangle. Now an isosceles triangle would have two congruent sides, meaning these are the only two sides that are the same. The next type of triangle is a scalene triangle. Of course the sides don't matter, but lengths themselves, but all that matters is the fact that they are different. So I can draw any type of triangle here. Obviously, by just a freehand triangle, this would have not the same sides. So having no lines in between any sides, through any sides, they are not congruent. Of course, the term can apply through over multiple triangles. You can have an acute scalene triangle. You can have an obtuse isosceles triangle. But these are just some vocabulary definitions for any congruence. Remember, the word congruent comes up a lot. Alright, so next in line for this presentation, I'm going to be talking about the relationship between angles. Now, there's a special bond between angles in a triangle. And nothing says it more than the next theorem that I'm about to state. It is the triangle. I forgot to write the angle there. There's some writing that you should know. Triangle angle sum theorem. Now, the sum of angle measures in a triangle is always 180 degrees. Please note that. Always 180 degrees. And there are some things that we can get from this. So next, we have corollaries. Now, just to refresh, a corollary is a theorem that comes from another theorem. So, given that we have that theorem, that every triangle, every angle measurement of a triangle adds up to 180 degrees. The first would be the acute angles of a right triangle are complementary. Complementary meaning adding up to 90 degrees. So since this is 90 degrees already, right, and we know that according to the angle sum theorem, it will add up to 180. So these two angles, let's label them maybe A and maybe B. So angle A and angle B would always add up to 90. Because 90 plus 90, I hope you know this, is equal to 180. So following that, there's also another corollary we can draw from this. And that is the measure of an equal angular triangle, all the sums together. I mean, like just one angle. Remember that we have three angles here, and then they would add up to 180, right? So if they're all the same angle, you could just say 180 divided by 3, and that would be 60 divided by 3. So the measure of an angle of an equiangular triangle will always be 60 degrees. Alright. Now we move on to describing the angles in a triangle. Now, interior and exterior angles. An interior angle would be any angle, obviously. Interior meaning inside, anything inside the triangle. So you can just say any angle in here is interior. Any angle outside here would be exterior. Now, of course, there's also, let's label these first. A, B, C, D. Okay. And a remote interior angle is an angle that is not adjacent to the exterior angle that you're looking at. So if you're looking at D, right, adjacent would be next to it, and you can see C is clearly adjacent to D. So that means that the remote interior angle in question, or remote interior angles, would be A and B because they are opposite of D. So a remote interior angle is an angle that is not adjacent. So these two are remote interior angles. Moving on. Okay, so now we have another theorem here. The measure of an exterior angle, sorry, I should have erased that. But the measure of an exterior angle of a triangle is the sum of the measures of its remote interior angles. So this angle, exterior angle D, we'll call it, would be equal to the sum of its the remote interior angles. So like I said before, A and B are the remote interior angles. So the angle D would be equal to A that's all you have to know about that. Alright. Now in writing, it's very important that we get it correct. And when you write a statement such as triangle ABC is congruent to triangle DEF, you're also stating which parts of it, the sides of the angles are congruent. So look at it, ABC, DEF, they're in order, right? So angle A is in the first position. D is also in the first position, so, sorry, this should be D. Well, let's look at the one that's correct, B and E. B is in the second position, E is in the second position, so angle B should be congruent to angle E, and C to F, and so on. In accordance to the sides, A and B here, the same as D and E, B, C, E, F, and so on. So when writing, it's very important that you must put it correctly, or else you could ruin the entire question you were trying to ask. So next. Now, there are many theorems that we could make for triangle congruence, and we're moving on to the median. Now, if three sides of a triangle are congruent, then obviously they will be congruent. This theorem, side, 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 or if you call it SSS, meaning, let's just put a couple of triangles here, and maybe this side is 6 centimeters, this side 7 centimeters, and this side 8 centimeters. So it would look the same. These triangles are different, right? But if we know that both sides are the same, all the sides are the same, then they are congruent. So if you base look solely on sides, then they will be congruent. The next one would be called the side angle side congruence. Side angle side, so side A side S, angle A and side S. So SAS. Now, if two sides in the included angle of one of the triangle are congruent with two sides in the included angle of another triangle, the corresponding ones, corresponding meaning the matching ones, then the triangles are congruent. Given this, we could make an example of this. This is a triangle, and this is another triangle. Now, included means, okay, so let's pretend these are the two sides that are congruent. If it's the side angle that is included, then we're talking about an angle in between. In between, this is included. It's in between, same here. This is in between these two sides. If it happens to be somewhere else, then this does not apply on the SAS. Right? So included being in between SAS. Alright? So next would be another type of theorem. This is the angle side angle, the opposite. ASA, right? Now, two angles in the included side, meaning again in between, the included side in between the two angles are congruent with those of another triangle, then they will be congruent, right? So clearly this is in between. So is this one. This side is in between these two angles. This would be congruent. Remember the symbol, the congruent would be this. Alright? My handwriting is terrible, but that doesn't worry you, I hope. Okay? Next, we have another type. This is called the angle side congruence. Now this is important because this is not included. So it is another theorem entirely. Now, the angle side congruence, meaning not included, means it's not in between, but to the next. Right? So if it's angle side, it looks something like this. Sorry. Diagrams, but I've never been really good at drawing triangles, so I'm not sure about it. See, this is not in between. Just to stress this, this is another type. It doesn't mean, like I said before, they are not congruent. Of course they are. Always there. So this is the side following, not included. Alright, so just one more vocabulary word for you. What is a hypotenuse? Hypotenuse is the longest side of a right triangle opposite of the right angle. So let's draw in here, we'll write the right triangle again. So the hypotenuse would clearly be this. This is opposite. Opposite meaning the other direction of something. So a right triangle's hypotenuse would be this side. This is also the longest side. Right? This is called hypotenuse. Right. So what do we need this for? Why did I bring this up? Well, the next one might be something you haven't heard before. The next one is the hypotenuse leg congruence. So if our hypotenuse and the leg of something, a triangle, are congruent, right? The leg meaning one side, then in fact it is also congruent. Right triangles, of course, they only have hypotenuses. So if these hypotenuses are congruent, as well as a leg, one of these, then these will be congruent. These are two different triangles. But these are right angles. Their hypotenuses are congruent, and also one leg on the side. Right? So in all of this, there is one acronym, is that right? Acronym that you should know. That is the next slide. The CPCT, which stands for corresponding part of congruent triangle. Now, while the previous theorems used, for the corresponding parts to prove triangles congruent, meaning that we use the parts to prove the triangles congruent, this acronym is used to reverse CPCT. So if we are given two triangles that are congruent, and we have we only know certain angle measurements or side measurements, then we know that all the rest should be the same. Let me give you an example. Okay, that's 3 times. So if I were to give you a question like that, and I give you another triangle, and I give you, like, this is 90 degrees, and this is maybe 45, this is 45. And I said that this is congruent to this. That means that you would know that this angle has to be 45 too. So does this one. And if this was 8 and this was 10, then that means that they would be the exact same values. So use it in reverse. Okay, that concludes this lesson. Can we have thank you? So, yes, please do comment, like, and subscribe. So, first this one. It's not working. I'm going to hold. Thank you.